Well, welcome to my talk about a cheapskate's guide to Azure. So, let's start. Who am I? Well, I'm the consultant, a bit of a nerd, and one strange fact, as a Norwegian, I'm a huge baseball fan since kids. And I've used Microsoft Azure heavily since 2009, and I enjoy talking with techies at conferences. So, if you see me walking around, come say hi. So, what are we going to talk about today? Well, first we're going to have a look at an introduction on why this talk might be needed for somebody. Then we're going to have a look at some common cost-saving tips and tricks. And then we're going to look at what I've called hidden costs. They might not be hidden, but they could have been. Then we're going to have a look at a thought process I use when I architect a solution called the Stinginess-scale. And then have a look at some possible quick changes you could do to your reference architectures just to save some quick money. So yeah, so why did I create this talk? Well, even though Azure might be worth it, there are reasons why I felt that this talk is needed. During my years as a consultant, I have observed a lot of strange behavior, especially by IT management. So I will start with two short stories. My first story is about one client that were moving from an on-prem solution to Azure. They received a good deal from Microsoft, but I could use Azure for free for 2 years. During this time, they lifted and shifted their on-prem VMware solution into the cloud. In a bit of a naive approach, the CTO told the developers to just go nuts with using Azure. They could use as much resources as they wanted to use because it was free, and the developers obliged. Before he announced this approach, I sat down with the CTO and told him that this would not be sustainable in the long run. They should have some rules for resource creation, like tags and other means of getting an overview of what got created and used by the developers. After having this conversation with him a few times, I gave up. He was not listening to me at all. So shortly after these conversations, I ended up taking on another client and moved on. 2 years later, when they have started paying for everything, the CTO called me up. He wanted some advice. They had just received their first bill from Microsoft, and it was 100,000 euros, basically for a month's usage. That was 1/3 of what their entire on-prem data center cost a year before. So he told me he tried to get an overview of what was created, but struggled a bit to figure out what was just garbage and what was production services. So had he listened to my advice in the beginning, this would all have been avoided. And this talk contains some of these tips, tricks, and other advice I gave him. In other words, the CTO, 6 months later, was not a part of the company anymore. My second story, that's a bit shorter, but also similar. This time, the client I was working with at the time was one of Norway's largest companies. They was also moving from an on-prem solution to a cloud-based solution on Azure. This time, the CTO had contracted Microsoft for advice, and had been talking with them for a while before I came part of the team. Microsoft had recommended some architectures and services that I thought was unnecessary and a bit of an overkill for them. The products in question were very good products for their use, but I personally thought that I could easily do without them. And I suspect that they would never really use all the features they provided anyway. And then later, they could provision the services if they were needed. When I asked the CTO about this, his answer was, and I basically quote this, "We are one of Norway's largest customers. I expect one of Norway's largest Azure bills." Very good start. So I did not even try to convince him anymore. He was stuck. He was locked in on a device from Microsoft, and I basically moved on again. So I experienced this a few times now. And I still believe some tips and tricks in advance on keeping cloud costs low are wanted. So I ended up creating this talk. But cloud costs can be a bit difficult to navigate and to do something with. There is no silver bullet in regards to cloud costs. That is because different cloud solutions have different needs. There are some costs I call hidden costs, mainly costs that people forget about. But my main goal is to inspire developers to think about costs the next time they create a cloud solution. And in an organization, it often starts with the developers, so you can nip the cloud costs in the bud. So how does Azure cost compare to AWS and GCP? Personally, I would say it's a bit of the same. Same, but different. You overall often end up with the same cost anyway, for the same solution. But how is this compared to smaller cloud providers? That is a bit more hard to compare, since the smaller providers does not offer the same services as the larger provider does. But if you were to compare basic infrastructure services like virtual machines, the smaller providers would almost in all cases come out on top. As an example, I have a server at OVH, the 6-core, 64 GB RAM, 1 TB NVMe disk, that cost me €100 a month. The same machine on Azure would cost me around €300, and that is with a lower IOPS. So if I would get the same IOPS I get with NVMe, I would have to pay even more. So yeah, they beat Azure on price, but not on services. So let's go into the first section of this talk. Let's start with some common cost-saving tips. Some of them might already be known for you, and some of them may not. The first one out is a well-known idiom. It's measure twice, cut once. This can actually also be applied to cloud solutions. But getting measurements can be a bit hard. But where you can get measurements, you should do it. And one of the tools that can help you with measurements are the Azure pricing calculator. If you use this together with all scenarios and measurements you create, then you can hopefully get less surprised when the bill arrives. Whenever I architect a new solution, I always have this calculator at the ready to compare different pricings for different possible scenarios that I can think of. Another maybe really obvious tip is to remove unused resources. But this can be way harder than one thing. Personally, I'm a big fan of tagging resources when I create them, using different subscriptions for different projects, and having naming conventions for resource groups and resources. This can help you to get a bit of an overview of what resources are used for and for what purposes. But it's more of a manual process. So there's a tool that can help with more automatic process. That tool is the Azure Advisor. It can help you find unused and underutilized resources. I've often received very good advice on both scaling and removal of resources using this tool. And you can also set up alerts to message you whenever new recommendations are available. And if you script something, you can also do that to automate stuff. Another thing that I see is forgotten about often is using development and testing subscriptions. This is something I very often see smaller companies forget even exists. They don't even know about it. And I suspect the reason for this is that they have not been in contact with Microsoft directly or with a cloud service provider that can help them. And using a dev and test subscription, you can get a discount on non-production workloads. So you can develop and test in the cloud with a very large discount. This one example here, that's actually something I stole from Microsoft documentation, so take it with a pinch of salt. You can get 50% discount on a typical web app with an SQL server using development and testing subscriptions. So this tip is a bit of a controversial one, but it's based on my personal experience, and it's become a bit of a cause for me. That is to move away from using virtual machines. VMs are great for many things, and they often have a place in our cloud architecture. But in my opinion, they are also overused. They're used for lift and shift and moving stuff into the clouds, on the existing on-prem solution into the clouds. But the companies often forget to start to move stuff bit by bit over to other Azure services. And they end up getting stuck with a solution that's almost the same as the one they had before, but now it costs around 3 or 4 times more. So just more costly. But if you still need to use VMs, can you manage with using Azure Spot VMs? Spot VMs are virtual machines that is intended for interruptible workloads, since you can get evicted from them at any minute's notice. Basically, you get 5-minute warning, and then your server is killed for you. So in most cases, this requires a bit of re-architecting of the solution to work. But if you can make use of Spot VMs, there can be up to a 19% savings on your Azure cost or VM cost as a reward. And a clear-cut case for using Spot VMs are as a secondary node pool on an Azure Kubernetes cluster. And if you can trim the primary node pool down to a minimum, and instead scale the cluster using a secondary node pool with Spot instances, you can shave large sums of your Azure bill. Another tip might be rather obvious, but in reality, it's not easy to accomplish. It's to scale down your underutilized resources. In a previous tip, I informed that Azure Advisor can help identify underutilized resources. But this is more a manual way of scaling up and down resources, even though you have alerts. There are a few ways one can accomplish this automatically. One way is to use the services that automatically scales up and down for you, using services that have auto-scaling. But if that is not possible, or not what they have done already, there still can be a way. You can do a little bit of scripting yourself and scale using Azure runbooks. Or if you're more into the no-code type of things, you could do the same in logic apps. And then you can set alerts using Azure Monitor on your wanted thresholds. And those alerts can execute the runbooks or the logic apps and scale your resources up and down as you see fit. It requires a bit more effort from your side to do this approach, but it's very often worth it in regards to long-term costs. Sorry. So, for services that offers different pricing tiers, have you checked that you're still using the best pricing tier available for you lately? Here's one example that I captured from app service pricing just a few weeks ago. Pricing tiers are not automatically updated when new ones comes along. So even though the prices rise a bit for each new version of the pricing tier, the cost per ACU goes down, and memory goes down every time. And using ACU as a compute unit, that's a linear metric or an estimate from Microsoft. You can get a picture of the available compute power by comparing it. So you get a lot more bang for the buck using the latest version 3 instead of sticking on version 1, 2, or as well. Another tip that I have, and this is where people discuss me the most, because it's a double-edged sword. And that is to use consumption-based pricing if or whenever you can. Consumption-based pricing is very often cheaper for services with a burst or non-linear usage of traffic. But here's the double-edged sword. The convenience of only paying for usage comes at a cost. So if your solution has a constant high usage, then using consumption-based pricing can easily become 2 or 3 times more expensive than using fixed pricing options. There are some services like Azure Functions and Cosmos DB that offer both fixed and consumption-based pricing options. And switching between them can be somewhat easy, like with Azure Functions, or it can be very much work and hard, like Cosmos DB. So having an overview of expected usage will help a great deal when deciding between pricing models. But in most cases, the usage is unknown. So when the usage is unknown for me, at the time of creating a solution, I tend to use consumption-based pricing for all my compute needs, since this is easier to migrate to a fixed pricing model later, and then using a fixed pricing model for data storage like databases, since those are harder to move later. So let's move on to Azure Hybrid Benefits. This is a licensing benefits that lets you use some of your on-premises licenses on Azure. As in this example here, you can save about 50% by using your existing Windows Server license on Azure. This tip might not be for everyone, but can be a large saver for those who are lifting and shifting their on-prem data center to Azure. Another tip that might not be for everyone, but can be a huge saver for those who use it, are Azure reservations. By committing to a 1-year or 3-year fixed plan, Azure reservations can give you a 55 to 80% discount over from the normal pay-as-you-go prices. You can pay a fixed monthly amount or prepay the plan you want. So here we see a screenshot that I also stolen from Microsoft documentation regarding the prices and the savings for the products examples. And if we have a look in Azure Portal, where we actually commit to this plan, you can see a more up-to-date pricing for the plan you want. So in these examples, I have Azure Synapse Analytics that costs $20,000 a month, and a typical Azure Kubernetes cluster that costs $2,000 a month, even with discounts. So those are expensive services anyway. A relative new product from Microsoft that was just released this autumn is Azure Savings Plans for Compute. This might be a bit intricate for me, at least for me and for some, but in this product you commit to a fixed amount to pay every month, prepaid or just paid every month. And it's only available for select compute type services. But the basis is that you pay a fixed amount for your expected usage. And if your usage is less or equal to the agreed upon expected usage, you pay the lower savings plan costs. And if your usage is greater than the agreed upon expected usage, then you pay the normal pay-as-you-go pricing for the amount that goes above the limit. Services available for this savings plan today are virtual machines, app service plans, Functions Premium Plan, Azure Container Instances, and Azure Dedicated Hosts. And my last tip in this section is that the last 3 savings options we just saw, they can be combined. So you can, for instance, have reservation, hybrid benefits, a compute savings plan on a select set of, let's say, virtual machines. And here I will try to figure out if any of these plans can be used at your organization, since these savings plans options give more value for the larger company you are. So small companies might not get that great a value from them. Using them on a solution with an unknown usage will often result in unnecessary costs. So if you don't know the usage of your solution, don't use them. But one can always start using these at a later time when the usage is known. So let's move away a bit from tips and tricks into a little section I called hidden costs. So what I define as hidden costs, those costs are small costs that one tend to forget about when creating a cloud solution. But all these small costs can easily add up to one larger cost, just as many small streams can create a large river. And one of these costs are data transfer costs. And the rule of thumb here is that data into Azure are free, and most, if not all, data out of Azure implies a cost. So they take your data hostage. Data transfer between regions also implies a cost. And here I've seen some clients that have created services across many regions without knowing this. And they've been surprised when they see the data cost on their bill. The prices in question looks quite innocent, but they can easily amount to large cost when they get added up. So 70 euro per gigabyte is actually not that cheap. Also, the prices for data transfer between regions, it's the same price as the outbound rate. So it costs the same. Another cost that really is not that hidden, but many tend to forget about, is data storage costs that are a part of some Azure services. One data storage cost that is often forgotten about is that VM disks, they still cost you money even if the VM is powered off. Another one is that Azure Function uses storage account to store both data and code. For normal stateless functions, these costs can be very much neglected. But for durable functions, For durable functions, these costs are often many times larger. That is because durable function also stores states in table storage, and they use storage queues. So for durable function, one execution from the user's point of view can be many more executions behind the scene, with a function starting and stopping and having to fetch and store its state multiple times. Again, these costs are very minimal, but small streams can create a large river. Another hidden cost is data redundancy in Azure storage accounts. Redundancy is great, but do you need it all the time? If you do not need data redundancy, can you manage with just zone redundancy or local redundancy? As an example, the price difference from local redundancy to geo-zone redundancy, the best one, is 65% price increase. And if you want geo-redundant data in Azure Storage Account, you have to pay 50% more of the data storage costs. If you can manage with if you can manage with zone redundancy, then it's just a 5% price increase from local redundancy. So can you manage with zone? You would save a lot of money using that. Azure Monitor, that is a cost that I see are often forgotten about, or very underestimated when I talk with clients. To elaborate on that, one of my clients, they had around 50% of their Azure bill just being Azure Monitor or application insights cost. And the worst of it was they never really used it for anything. The reasoning behind this was that, well, they might need it someday. They never needed it. According to Microsoft documentation, the median data ingestion for Azure Monitor is around 3 gigabytes a month. I take that with a pinch of salt. Note that alerts, notifications, and queries on the data also cost you extra. So for an alert where you check something, let's say every 15 minutes, you pay for the query of the data, and you also pay for the alert if it's sent. Any data sent to third parties like Datadog and Elastic has a cost per gigabyte of data transferred. And this is something that I see people don't think about. It's that there's two log types. There's analytics logs and basic logs. Analytics logs are 3.6 times more expensive. If you want retention of your log data up to 2 years, you can use analytics logs. Go for it. Otherwise, just use basic logs. It will fit most needs. Application insight logs are priced the same as analytics logs. And lastly, don't be like the client I mentioned. Do not send in unnecessary logs and metrics. It just costs you a lot of money. So yeah, in this next section, I will explain an internal tool that I use to help with selecting what services to use when I create architectures for clients. I call this tool my Stinginess-scale. And I use this tool to more easily compare different services against each other in regards to costs when I architect solutions. This scale consists of a few points that I try to answer to myself for the service in question that I'm looking at. The first point is, how easy is it to estimate costs for that particular service? Then I try to set up a small to medium production usage scenario in the pricing calculator and see how much that would cost me. I then check to see if the service have a consumption-based pricing model. And then I see, does it have a free tier? And can that free tier be used for small users or just development and testing? And I checked if it has, see if it has a tiered pricing model. And lastly, I check if the product is any good. Does it solve all my needs? And or does it come with unnecessary bells and whistles that often implies extra costs? So I only have 40 minutes for this talk, and I've used almost 30 minutes of them. So I've just done this scenario for one product. I've basically shown the process for one product. So yeah, we won't be comparing different products today, sorry. So I've chosen to do this for Cosmos DB. So okay, Cosmos DB, I think it's known for everybody, but let's do it in 30 seconds. It's a globally distributed NoSQL database with promises of single-digit responses and automatic and instant scaling. It supports key value, column, document, and graph types of data, and have multiple types of APIs you can use. That's the end of the sales pitch. Sounds like a great product to me, right? Well, for me personally, I think that many of these features falls under my bells and whistles category, and can actually be a bit too much for some use cases. So I keep this in mind in regards to the solution I'm architecting and the case itself. So how easy is it to estimate costs for Cosmos DB? Well, you have to know a lot of variables in advance to get a good cost overview. And even though they have a ready-to-use calculator for exactly this, I think it's very overwhelming just to do this. Personally, I have never, ever been able to correctly estimate Cosmos DB costs, ever. Then I have a look at the pricing models and tiers available for Cosmos DB. And I see that it has a very limited free tier that are only available for new accounts and have to be manually enabled. Then I see that the normal pricing model is a standard provision throughput where you can use the previous shown calculator and calculate an amount of needed throughput units per second that you want to provision. They also offer an auto-scaled version where Cosmos DB will try to scale for you. Then there's a consumption-based pricing model, where you only pay for the amount of throughput units that you actually use. And then now there's a new distributed PostgreSQL part of the product, where there's a fixed vCore and memory model, where the fixed vCore model where you only pay for the nodes and the CPU and the memory. So how much does this cost in a normal production usage, or basically a small to medium production usage? Well, first I check for an unrealistic 100% usage of the service. Here we can see that the cheapest pricing model, that is the manually provisioned model. The auto-scale model is a bit more expensive, but you pay for the convenience of not having to scale yourself. Then the most expensive option, but in this scenario, by far, is the serverless consumption model. And then I check for 24% average usage. This is a normal work week with 8-hour workdays to simulate a typical back office usage. And for a 24% average usage, then we see that the manually provision model is still the same. The auto-scale model becomes a lot cheaper, and the serverless consumption-based model is still the most expensive one. I have to admit that this 24% scenario is usually where the other consumption-based pricing model shines, but not for Cosmos DB. So what are some alternatives one can use instead of Cosmos DB? Obviously, there's Azure SQL that can be used if you do not need to use a NoSQL database. Then there is PostgreSQL that have some NoSQL features that can be added as extensions, like document database and graph database. And if you just need to store some simple key value type of data, then there's Azure Table Storage. So how does these compare to Cosmos DB in regards to pricing? Here we can see that the alternatives range pretty similar to the manually provisioned pricing model. Personally, I prefer to use table storage whenever I can. It has some limitations in regards to latency and such, but if you can make do with it, then there's a lot to save. Yeah, there. So, how would I score Cosmos DB using my Stinginess-scale? For ease of cost estimation, I have to flunk it. This is not an easy task. It's almost impossible, I think. For production usage pricing, I give it an 8 over 10. It has a very passing score. It's not that expensive compared to the alternatives you can use. For consumption-based pricing, I also have to flunk it. The reason for this is that it's not very accessible and it's very limited in its use. It does not have any tier pricing model. Oh, sorry, free tier, yeah. Sorry. It doesn't have any tier pricing model, so that is not applicable. And is it a good product? Well, I say yes, but it has a bit too much of those bells and whistles for me to give it a top score. So, last few minutes of this talk, I'm going to go through some architecting cheaper cloud solutions. So, as we started this talk with, there is no silver bullet when architecting a cheaper cloud solution. But I want you to think about some of the tips and tricks we just went through, and how we can apply them when creating a new solution in Azure. So this is another exercise I do myself when I start a new project. I try to figure out if the solution is expected to have a very constant usage without any or few usage spikes, or if the usage is unknown or variable with many possible usage spikes. If the usage is somewhat constant and known, I still check to see if the fixed pricing, if a fixed pricing option is cheaper than the consumption-based pricing option for the product. If that is not the case, then I go for products with a fixed pricing model. If, however, this is the case, then I go for products with consumption-based pricing models. When I perform this exercise, this is where I end up in most cases. There are some exceptions, especially for solutions that are heavy on data analytics, then I do end up there. But sometimes, when you start a solution with a variable or unknown usage, then there can become a time where the consumption-based pricing model becomes more expensive. Then one can move from a serverless and consumption-priced model to platform or infrastructure services with a fixed tier or tiered or fixed pricing models. As an example, Azure Function and container instances can easily be moved to a tiered app service plan. So what type of compute services do I prefer when I want to have a cheaper solution? I try to use functions, app service plan, container instance whenever I can. And I often combine them. Unless I really need it for some requirements, I try to avoid using virtual machines and services like Kubernetes service and Service Fabric that uses many of them. For database type services, I first check if I can make do with a simple table storage. That's my go-to. If not, then I see if I can use an SQL server instance or PostgreSQL server instance, especially if the solution does not require the usage of NoSQL databases. Then if it requires the usage of NoSQL databases, I check, can I use Postgres? And if not, then I use Cosmos DB. An SQL managed instance is something I avoid like the plague. They're good for migrating data, but not much else. Use them a short while, get over to Azure SQL, be done with it. Kill the instance. Yeah, so in closing, we're going to have a look at 3 reference architectures from Microsoft. This one is stream processing with Azure Stream Analytics. You can find these architectures at their reference architecture archive. So here we have a solution with Azure Event Hub, Stream Analytics into Cosmos DB and Power BI. Pretty cookie-cutter solution from Microsoft. But if you change Cosmos DB to table storage, since this solution here don't require single-digit latency or globally distributed data, you can save a lot of money with adding some more latency to your data using table storage. There's no need to actually use that. So I think you can shave off 75% of your cost on the data storage cost just using that. Then another architecture is image classification on Azure. Same thing here. They used Azure Cosmos DB. It's good, but do you really need all the bells and whistles and features it offers? If not, then you can pay a lot less creating the same solution using table storage and blob storage. That will also shave off a lot of your money. So there's a trend here. And last architecture I'm going to do right now today is something they call design review powered by mixed reality. Here they use Azure Kubernetes service and to host some containers that are talking to the HoloLens. But do you really need to use Kubernetes service and a cluster for that? You can save a lot of money just using app service plan and scale with that instead. So basically using these small tips and tricks and very small changes, you can shave off large costs of your architecture. So where do I go from here? Well, every talk I give, I inform about Microsoft Learn. This is a product from Microsoft I absolutely love. It has interactive tutorials, so you learn by doing. You get an Azure sandbox for free, and everything gets cleaned up after you. No need to do it on your MSDN subscription and burn all your MSDN money. And even though it's mentioned before, the Azure pricing calculator is an invaluable tool when navigating the costs of Azure. So, what have we gone through today? Well, we had a look at common tips and tricks for reducing costs. We had a look at hidden storage and bandwidth costs, some of my mental tools to compare services, and some very small changes you can do to your architectures to save basically a lot of money. So that's me. Thank you.